Hello, everyone. This is for a review on Chapter 12, some important aspects to know. And that chapter is water and major minerals. So water accounts for, how much is that? About 60% of the adult's body. And that varies with regard to the proportion of lean to fat tissue one may have. You could see that lean weight at 75% water, where compared to 25% in fat tissue. Water very important, carries nutrients, carries waste, maintains structure of large molecules, participates in metabolic reactions, serves as a solvent, a lubricant, a cushion agent, aids in regulation of body temperature, maintains blood volume. Oh, we have the answers shown there, intracellular, and that is inside the cell, interstitial, between and surrounding the cell, extracellular, outside of the cell, and intravascular, that relates to the blood. We see a schematic of the cell, intracellular, extracellular, and the plasma or intravascular. Electrolytes, these are dissociated salts into ions. Ions are cations, which are positive, anions, which are negative. These compose our electrolytes. And they are in certain concentrations, very important to keep certain concentrations inside and outside and in the bloodstream. Electrolytes are, to a large extent, responsible for this balance of water. The electrolytes attract water due to their charge. Electrolytes are considered solutes, that is, they're dissolved in water. When we say salt, oftentimes we think of table salt, NaCl, sodium chloride. Sodium chloride dissolves in water to its ions, sodium ion, cation, and chloride, negative ion. Osmosis is the important chemical reaction you need to know when talking about water. That's the movement of water across the membrane to decrease pressure to reach equilibrium between electrolytes that may be on either side of the membrane. Proteins, large molecules, attract water, and if not regulated or cell membranes might not keep their integrity, you might have edema, that is an attraction of more water than usual, and that is swelling. Here we see the schematic of the chemistry involved with electrolytes and water. You can see water having negative side and positive side due to the oxygen and the hydrogens. And you can see the corresponding sodium chloride ions, sodium positive attracted by the oxygen side of water, and chloride attracted by the hydrogens component of water. Osmosis, that chemical process that we should know about when a raisin is placed inside a bowl of water. What should we expect? Well, water would move into that raisin. This is because the sugar, that is the solute concentration, is higher inside of the raisin compared to outside, and osmosis occurs in attempts to equilibrate that concentration. It's an example of osmosis, of course, where water moves from an area of low solute concentration to an area of high solute concentration, as we said, and to try to reach equilibrium. And here's a schematic. You could see in your book what might happen here. One shows about equal concentrations on both sides, but if they had more solute in number 2 to B, see water moving into the B compartment across the semi-permeable membrane to equilibrate or make the concentration of B and A be similar or equal. And this is a process that occurs in our body, fluids maintained, blood volume and pressure regulated by kidneys. We adjust the volume of water and its concentration, adjust concentration that goes out in urine. Antidiuretic hormone, or ADH, is that hormone that conserves water, and that is present, stimulates the kidneys to reabsorb water. It's released by the hypothalamus to stimulate the pituitary gland. And of course, events that trigger thirst, which indicates that we need to take in more water to continue to keep the fluid balance. So the kidneys are the central regulating organ of blood volume. And they do this by adjusting urine volume and concentration. ADH is released in response to dehydration. It simulates water to be reabsorbed in the kidneys. So that's the hormones involved and the explanation. This all happens to maintain homeostasis. So renin is the enzyme released by the kidneys. This occurs when the blood pressure is low. Renin causes sodium to be reabsorbed, which is accompanied by water reabsorption. Angiotensin II, another hormone, is a powerful vasoconstrictor. It is constricting the blood vessels. This means that it raises blood pressure. The renin is required to convert angiotensin to angiotensin 1. Angiotensin 2 also stimulates the release of aldosterone, another hormone that signals the kidneys to excrete potassium and retain sodium. This in turn stimulates the retention of water. Here is a cartoon of the functionings at the level of the nephron. Is more than 1 million nephrons in the kidney, and they each operate to maintain homeostasis of fluids and electrolyte. Here's that sequence of hormones, starting with the trigger of blood pressure and blood volume. When it's low, releasing renin. They're converting angiotensin to angiotensin 1, which is converted to angiotensin 2, constricting blood volume, increasing blood pressure, along with ADH and aldosterone. Working on concentrations of potassium and sodium. Sodium is indiscriminately lost, vomiting, and diarrhea. This could cause electrolyte imbalance. Other cause of fluid electrolyte imbalance are heavy sweating, burns, traumatic wounds. Medical intervention depends on the circumstances surrounding the loss. What does ORT stand for? So we should kind of recall that. That's oral rehydration therapy. And here's a general recipe for what that would be. About 4 teaspoons of sugar and a half a teaspoon of salt in half a liter of water. And that is about 2 cups. To dissolve the sugar and the salt in water, you'd have to heat up the water, maybe to boiling, to dissolve, and then cool it. And that's ORT. So another thing we talk about when we're thinking about water and electrolytes, and that is acid-base balance in the body. The iron's very important in regulating the acid-base volume or the acidity. The body wants to retain a narrow range of pH around neutral to avoid life-threatening consequences. As out of the pH range starts disrupting, denaturing proteins critical, could be enzymes, antibodies, membranes, etc. So pH range adherence, extremely important. And just to recall, high concentration of hydrogen ions is acid or acidic, and a low concentration would be basic. We regulate the pH with buffers. 3 major buffering systems operate in the body. And buffers neutralize acids and bases, maintain body fluids at approximate neutral or a little on the acidic side. Carbonic acid from CO2 in the blood and bicarbonate is the major buffer in our bloodstream. Respiration in the lungs, another way that we regulate pH. We could increase or decrease pH by lung decreasing or increasing lung respiration. If we, for example, if we hyperventilate, or remove CO2 from our system, we would increase the pH or decrease the acidity. Another way to regulate pH would be excretion by the kidneys. Bicarbonate could be excreted, and that would serve to decrease pH. Urine acidity fluctuates, and that's a way to also regulate, moderate pH. Here's an example of a major buffer system in the body, and that's the bicarbonate system. You can see that the CO2 and water interact to form carbonic acid. That carbonic acid gives off a proton or a hydrogen ion, decreasing the pH. So if we increase or decrease the carbon dioxide in the system, we can decrease or increase acidity to make sure we stay in the critical pH range in the body. And with regard to the amount of water we should be maintaining in normal functioning homeostatic body, a minimum of 500 milliliters of water is excreted in waste. The amount of water we need to carry away waste, that is, in the urine, 500 milliliters. Beyond these losses, there's also losses, and how do we balance those losses? And that's with intake. Losses also depend on environmental conditions. It's temperature, humidity, primarily. Daily losses are an average about 2,500 milliliters. That's about 10 cups. How do we get signals with regard to, are we taking in enough water? Well, thirst and satiety should do it, but we could become dehydrated before the trigger of thirst and satiety. Urine is another way to look at our water balance. Our color, see on the right there, approximate colors of urine, which normal, whether we're overhydrated or dehydrated. Dehydration could be very problematic. If we lose as little as 1 to 2% of water, normal water volume, could trigger weakness, fatigue. 3 to 4% start impairing physical performance. 5 to 6% of loss of our normal kind of amount of water, be difficult concentrating, headaches, irritability, sleeplessness, etc. seen there. 7 to 10% could become very dangerous. Dizziness, loss of muscle control, loss of balance, exhaustion, collapse. And where do we get our water? Which of these is correct about the water source or our water sources? Is it water in the diet? Is it water, fruits and vegetables? Is it water and food and metabolism? No, it is all those. Yes, indeed, water sources come from beverages, the most obvious, but also significant amount from food. And our normal reactions in the body actually also produce water, mostly at that end point of producing ATP, where water is also a product. Water losses, shown there at the right, and taken out by the kidney with waste and sweat, are uh, keeping our temperature, body temperature under control, and even in our breath and feces totaling. Foods, some foods, very high percent of water, some no water. Fruits and vegetables, very high in water. In the middle there, you see meat and pizza, cheese, and no water in oils, sugar. So there's adequate intake numbers for us, 2 to 3 liters, that's 8 to 12 cups. And this varies from person to person in regard to uh, weight and age, and also, of course, activities, what kind of beverages one consumes. Health effects of maintaining the proper intake of water, physical and mental performance, proper functionings, flushing of waste out of the body, blood volume, GI tract functioning. Hard versus soft water. It's just a comment there. Hard water would include more minerals, which most of the time is good. That means calcium and magnesium, phosphates. On the other hand, it's not good for washing. Minerals overview. Okay, now we'll look at the major minerals. Let's go through some highlights about them. Minerals are blank substances. These are inorganic, which means they are not destroyed by heat, air, acid mixing. Compare that to things like vitamins. They are organic and they could be destroyed by heat, air, acid. Some foods contain binders. That's another name, chelators, that could impact the mineral bioavailability from foods. Two examples are phthalates and oxalates, which occur in foods of plant origin. Some vitamins in excess of the minerals can create inadequacy of each. So this could mean supplements might impair our absorption of minerals. It's a nice figure from the book with minerals comparison of the major minerals. See at the top, most is calcium. A few pounds of calcium. Phosphorus, those two, of course, major components of bone. Potassium, sulfur, sodium, chloride, magnesium, and then the trace elements, low amounts, but just as important. So the first mineral, sodium, to look at, but their principal cation, that is a positive ion outside of the cell, extracellular fluid. They regulate the volume around the cells, as with water. They're active in acid-base balance, nerve transmission, muscle constrictions. Sodium travels freely, very water soluble. All ions, electrolytes are. Kidneys filter them out and return them as needed. That's the job of the kidneys. Sodium deficiency is rare. Why is that? Well, sodium is very common in foods and water we take in. On the other hand, sodium is correlated with hypertension or high blood pressure. Because of this, there's an upper limit, and that upper limit is 2,300 milligrams. And most Americans exceed those recommendations. By the way, that 2,300 milligrams is about a teaspoon. Sodium is mainly consumed as table salt, sodium chloride. Adults with prehypertension or hypertension are recommended to have a lower intake, around 1,500 milligrams. Eating plans, especially to lower sodium intake, are called DASH, and they restrict foods that are very high in sodium and very higher in, as you'd expect, fruits and vegetables. And DASH is an acronym for Dietary Approaches to Stop Hypertension. So what about, in addition to hypertension, high salt intake is associated with increased excretion of calcium. Potassium, on the other hand, is a protective factor. So potassium makes potassium a very important nutrient. So hypertension could come along with, unfortunately, bone erosion, overexcretion of calcium. So two negatives there of high intake of sodium. DASH diet, and most recommendations are to decrease processed foods because they very often have relatively high amounts of sodium. You can see this this figure from the book. You can see when we take unprocessed milk and make it processed, we increase the sodium, decrease the potassium. Take roast beef, corn, peaches, rolled oats, which start out primarily or mostly having a relatively high concentration of potassium, which is good. And then when they're processed, we increase the amount of sodium at the expense of the potassium. Sodium deficiency. We said that's rare, but in extreme cases, this could cause a condition called hyponatremia. This could occur with ultra endurance athletes with sweating. It also could be when water is overconsumed. It's rare, but that once in a while we hear cases of, especially in summertime, and now might become more common with the sweltering heat, especially in parts of the US. People might not realize that they're over-consuming water, and we might see more of this condition. Acute symptoms of excessive sodium are edema. Mentioned that it's swelling because proteins accumulate and attract the water. Might actually break cells, cause problems with higher pressure around cells, and high blood pressure. Prolonged excessive sodium contributes to hypertension and high blood pressure. The other part of table salt, the chloride, is also an essential nutrient. Plays a role as the major anion or negative ion in extracellular fluid, maintaining charge balance, passes easily across membranes associated with sodium and potassium, maintaining balance. Also is an important part of, well, it's a part of that our body produces hydrochloric acid in the stomach to assist in protein digestion. Chloride's also abundant in foods, especially processed foods. If a deficiency occurs, again, that's very rare. There could be signs of tension, maintenance of water balance. Potassium, really important mineral, often deficient in foods because of primarily from intake of ultra-processed or processed foods dominant in a diet and an eating pattern. The roles of potassium, again, along with the other electrolytes we're mentioning, to maintain fluid balance. It's part of cell integrity, that balance inside and outside of the cell. Aids in nerve transmission and contraction. It's processing destroys cells. So we're talking about plant cells predominantly in an eating pattern. So if we destroy cells, we would lose potassium. Therefore, fresh foods, unprocessed foods, are the richest form of potassium. Potassium has an adequate intake of 4,700 milligrams per day. Diets low in potassium could be prone to hypertension or higher blood pressure. So to meet potassium needs, people are recommended to consume more fruits and vegetables that are fresh and not processed. Deficiency of potassium we said could lead to higher blood pressure, kidney stones because of imbalance and bone turnover, loss of calcium. Could also lead to irregular heartbeats, muscle fatigue, and glucose intolerance. There's no upper limit, so overconsumption from supplements or potassium salts are not a concern. And the kidney could accelerate its excretion if concentrations are high. See at the bottom, excellent sources of potassium include plants, especially squash, soybean, which would be tofu, soy milk, and artichoke. Had many other vegetables, as you can see, broccoli, carrots, potato, and fruits, banana, orange, strawberries. Calcium, most abundant mineral in the body. Need this for adequate maintenance of our skeleton, especially early in life and late in life, when bone tends to become more at risk. Majority of the calcium in the body are in bones and teeth, part of that structure. That is the calcium bank, the bones. In the body fluid, calcium maintains normal blood pressure as one of those important electrolytes. It's an extracellular part, participates in blood clotting, while inside the cell, it binds proteins to activate them. It's act as a messenger, a regulator, activates some enzymes, so really critical mineral. Calcitonin, okay, calcitonin, that's a hormone that is released when calcium is high. The effect that calcitonin has on vitamin D, well, it activates vitamin D. That inhibits prevention of calcium reabsorption. So more calcium will be excreted. Parathyroid hormone. This stimulates vitamin D activation. This enhances calcium absorption in the intestine. In the osteoclast cells release, these are bone cells that release the calcium into the blood. And PTH raises blood calcium levels. So several different processes, including hormones, that regulate the calcium to keep it in balance. So we could see a number of organs involved in blood calcium balance, including blood, kidneys, intestine, and bone. So the recommendations are set high often. Often calcium is a nutrient that is deficient in many diets for a number of reasons. Absorption rate is not great. About 30% absorption rate. That depends on nutritional status, health status. Calcium, very important throughout the life cycle for different reasons. Early in life for active bone growth, bone mass reaching max around 20 years, and then starts declining, and bone loss is fought throughout much of life, so the intake of calcium extremely important. And sources in the diet shown here, sardines with the bones, almonds, bok choy, and dairy. Osteoporosis. That's osteoporosis. That's porous and fragile bones. It's a silent disease. It may not be recognized until one might break bones easily, or get a DEXA scan ordered by a physician. Peak bone loss around your 20s, and bone loss begins, typically it begins 30 to 40 years of age. Osteopenia, low bone mass. Phosphorus, second most abundant mineral in the diet, makes up these hydroxyapatite crystals, which are make up strength of bone in teeth. Other roles of phosphorus, they're components of buffer system, DNA and RNA and system energy, part of ATP system, transports, part of transporting lipids in blood or lipoproteins, structural component of cells. Phosphorus is pretty abundant in lots of foods. Most abundant is protein-rich foods. Toxicity is rare. There is an upper limit given at 4,000 milligrams. Here you see some common sources of phosphorus. You can see dairy, meats of various types, and fruits and vegetables. Magnesium. This is also very high concentration and strength of bones, more than half of component of bones. It serves also as a reservoir, so it maintains strength of bones. It's also involved in energy, ATP production. It's a part of our muscle contraction mechanisms, involved in blood clotting, supports normal function of our immune system. Legumes and nuts, leafy green vegetables are good sources. Typically, U.S. population is low in their intake of magnesium, which could exacerbate inflammation and chronic diseases. Though deficiency, full-blown deficiency rarely occurs. It is protective against hypertension. Again, it's present in hard water. So hard water is preferable over soft water. So there's some good sources. And this is also just as a comment, this is per serving shown on these figures. The amount per serving. You see the RDAs out at the right, but this is just per serving. It's just comparative type charts. You can see at the bottom the excellent sources, and so the ones, of course, that are highlighted at the left are recommended as good, and a variety of sources. See broccoli, pinto beans, tofu, halibut, cashews, artichoke. And finally, as a major mineral, we mentioned sulfate. Sulfate, we say sulfate because that's how we get it typically in our eating pattern. Could be in foods or beverages. It's important because it's a part of a couple of amino acids, methionine and cysteine. There's no number given in recommended intake, and normal intake of protein usually is sufficient to get enough of the sulfate that is required. Finally, a highlight in chapter 12 is the importance of calcium and osteoporosis as called the silent disease. That is, symptoms are along the way are mild. You don't see the symptoms until we reach severe, and that's usually later, older people. But with older people, it unfortunately is common, and it shows up in hip fractures upon falls. And it's because of loss of strength of important parts of the bone. There's other risk factors involved in osteoporosis shown here. Sedentary lifestyle, smoking, alcohol use, overuse. Genetics are likely to influence our bone health. And we'll stop here.